In this one, I'm going to show you how you can remember the Cauchy-Riemann equations in complex analysis. So what you can do is write that, for example, f is your function. It has these components u plus vi usually. A way to remember the Cauchy-Riemann equations means that you can write that v sub y is equal to I times v sub x. That's it. So why does this work? Well, if you expand this equation, so let's say this is 1 and then this is 2. If I expand 2 into its components, it will look like the following. On the left side, take and differentiate step 1 here with respect to y. So I would have, carefully now, u sub y plus v sub yi, and then I differentiate according to the right side of step 2, so that's with respect to x, keeping that I in front of everything, right? That. So that will give me u sub x plus v sub x, and then with the I. What I can do now is distribute the I at step 3 to each term on the right side this way. So now I will have the following: u sub y plus v sub yi is equal to I u sub x plus v sub x I squared. But remember, as a side note, that I squared is -1. So what I can do is replace this at the next step as u sub y plus v sub yi equals I u sub x minus v sub x. And then from step 5, you can read off the Cauchy-Riemann equations. So you can say the following as a conclusion, that the u sub y on the left side must be equal to the negative v sub x on the right side, because this is the real part here and this is the real part here. They have to be equal. That's what makes complex numbers equal. They have to be equal in their real parts and their complex parts, or imaginary parts rather. So I would say the following: u sub y is equal to negative v sub x, and the other part must be therefore that v sub y is equal to u sub x. I would say that v sub y is equal to u sub x, and then these are what I will call the CR, or Cauchy-Riemann equations. All of this is premised essentially on step 2, and do remember that in all of this, when you plug in particular values for u and v, then in the end all you have are complex numbers, and that's it. In other words, basically little numbers that look like this. So if you look at step 2 carefully, that expresses also a kind of geometric relationship between the derivative with respect to y and the derivative with respect to x. I'm not saying that it's this one here specifically, but it is present at step 2. If you think about it, perhaps you'll discover it. That's all I want to say here. Thank you so much. Please leave a like and subscribe. I'll see you in another video.